an interstellar object whirling through our solar system is actually a nuclear-powered spacecraft sent by aliens?
We've got some fresh images of 3I Atlas, a third ever interstellar object observed from Earth.
Far beyond the orbit of Jupiter, a silent traveler drifted through the black gulf between the stars. The object, cataloged as 3Y Atlas, was already famous for being only the third interstellar visitor ever confirmed within our solar system. Unlike asteroids or comets that loop back around the sun in predictable paths, interstellar objects carry stories from other star systems, having broken free from their birthplaces to wander indefinitely. Astronomers had been watching 3Y Atlas closely, charting its trajectory, analyzing its composition, and running endless simulations of its path. Yet none of the data prepared them for what happened when something unexpected slammed into it. Before we start, smash the like and subscribe buttons for more updates. The moment was first noticed as a flicker in the telescope data. Light curves shifted abruptly, as though the interstellar object had momentarily flared brighter before settling into an altered pattern. At first, the possibility of a mere sensor glitch was considered. But within hours, observatories across the globe confirmed the anomaly. A collision, something massive and unanticipated, had struck 3Y Atlas as it passed through the outer reaches of our system. The impact was not just another cosmic pebble tapping against stone. The violence of it left signatures that shook astronomers with both excitement and dread. The sheer improbability of such an encounter magnified its mystery. Interstellar objects are rare enough on their own, let alone being struck by another body in the deep void. The cosmos is unimaginably vast, and collisions between random objects are exceedingly rare outside of dense regions like asteroid belts. Yet here, in our astronomical backyard, a foreign traveler had been intercepted. The mathematics alone seemed to defy expectation. For the event to occur, both 3I Atlas and its assailant had to align perfectly across billions of cubic kilometers of space. It was like two grains of sand colliding in the middle of an ocean. What made the event even more unsettling was the size of the impactor. Observations suggested it was no small fragment of debris. The energy released implied a body dozens, perhaps hundreds of meters across. Not a dust grain, not an invisible speck, but a true spacefaring mass, silent and unseen until the moment of collision. For astronomers, this raised uncomfortable questions about just how much of the universe remains unseen around us. If something of that magnitude could remain invisible until it met another interstellar wanderer, what else drifts undetected through the black? The immediate implications rippled through the scientific community. Suddenly, 3I Atlas was no longer a passive object to be studied at leisure. It had become the site of an event, a natural experiment unfolding in real time. The collision stripped away portions of its surface, casting shimmering trails of debris into space. Spectrographs captured signatures of materials not previously detectable, unlocking secrets of its composition that would have otherwise remained hidden. Elements and compounds that formed in another star system now glimmered in the void, free to be measured by human eyes and machines. The opportunity was both thrilling and chilling. Thrilling because the data could reshape our understanding of planetary formation beyond our sun. Chilling because of what such an impact suggested about the unseen perils of space. Scientists knew immediately that the trajectory of 3I Atlas had changed. The impact was not a minor nudge, but a profound alteration, twisting its hyperbolic course. With that alteration came the uneasy recognition that such objects, even from other systems, could become unpredictable after interactions like this. If an interstellar body could be deflected, there was always the slim but real chance it could one day be turned inward, toward Earth itself. While 3I Atlas remained far from being a direct threat, the principle was unsettling. The cosmos is not just vast and empty, but also full of sudden violence that can rewrite trajectories in an instant. Amid the calculations, other mysteries emerged. The light curve following the impact suggested not only reflective debris, but also something more complex. Some wavelengths showed a faint pulsing, as though volatile materials beneath the surface had been exposed and ignited in strange chemical reactions. The very makeup of 3I Atlas seemed less inert than expected. Unlike most frozen comets that steadily release gases as they approach the sun, this interstellar visitor had now been cracked open in a way that revealed volatile layers interacting in unexpected ways. It was as if a sealed message from another star had been violently opened. The scientific possibilities ignited discussions across observatories. What if the impact revealed compounds unique to 3I Atlas's home system? What if its chemistry was unlike anything in our catalog? Already, hints of unusual isotopes teased at answers to long-standing questions about interstellar matter. Some spectra hinted at compounds rich in exotic carbon chains, structures that could have implications for the origins of complex molecules. To stumble upon such a find, triggered by an unpredicted collision, felt like chance bordering on destiny. Yet awe carried its shadow. If bodies the size of the impactor were roaming unseen, then the risk to planets, including ours, loomed larger than ever. Earth has always been vulnerable to asteroid strikes, but the thought of interstellar debris sweeping silently through the solar system added another layer of uncertainty. Unlike familiar near-Earth objects, these wanderers cannot be mapped into stable catalogs. They appear suddenly, streak across our sky, and vanish again into interstellar night. When they collide, the consequences are amplified by their immense speeds, often tens of kilometers per second faster than local asteroids. The energy released in even a moderate impact would dwarf anything humanity has prepared for. The silence of space made the event all the more terrifying. No warning, no gradual buildup, just an object wandering through the void struck by another and instantly transformed. There was no alarm to sound, no siren to wail. Humanity's best instruments merely caught the afterglow, the faint flicker of light from an impossible collision. That silence carried an eerie weight. It reminded us that while our telescopes scan the heavens, the universe does not bend to our expectations. Things happen out there without our consent, or our foresight. In the aftermath of discovery, debates raged about what this meant for our understanding of cosmic traffic. Some argued it highlighted the desperate need for better sky surveys, more vigilant detection systems that could map even faint and fast-moving bodies. Others saw it as a humbling reminder of cosmic chance, that no matter how many instruments we build, the universe will always retain its ability to surprise, and sometimes to terrify. What struck 3I Atlas was not just a collision between rocks, but a collision between expectation and reality. The broader implications stretched into philosophy as well as science. To witness something foreign from another star, struck and shattered in our own celestial neighborhood, stirred a primal awareness of connection. The cosmos is not neatly compartmentalized. Our solar system is not isolated. The events out there reverberate with meaning here, reminding us that we are part of an ongoing story written in collisions, chance encounters, and cosmic upheaval. Astronomers pored over the new streams of data, some exhilarated, others unsettled. The more they measured, the clearer it became that the collision was not just an accident, it was a revelation. It tore open a veil, showing us that the interstellar medium is alive with objects large enough to reshape our understanding of risk and opportunity. For every dazzling spectrum captured from 3I Atlas's debris, there was the sobering recognition that countless other wanderers roam invisibly, each carrying the potential to collide, to disrupt, to terrify. The event became more than a footnote in astronomy. It was a vivid demonstration that the universe is active, dynamic, and mercilessly indifferent. A silent strike in the depths of space had turned a solitary traveler into a cosmic spectacle, rewriting our models and challenging our assumptions. It was terrifying not only because of what it revealed about 3I Atlas, but because of what it suggested about the endless hidden collisions taking place beyond the reach of our eyes. And so, the image remains. A foreign visitor drifting across our skies, suddenly struck by something no one expected. In that instant, the universe reminded us of its scale and unpredictability. We look to the stars for wonder, but sometimes they return our gaze with something far more unsettling. Something that forces us to reckon with the truth that in the cosmic ocean, no traveler is ever truly safe, not even those just passing through. When the shock of the collision spread through the astronomical community, the immediate reaction was astonishment, but astonishment soon gave way to curiosity. What had once been a single enigmatic body drifting along its interstellar path was now a laboratory of fractured material, a natural experiment on a scale no human mission could hope to replicate. As astronomers probed the aftermath of the impact, they began peeling away layers of meaning, exploring dimensions that went far beyond the mechanics of two objects striking each other in the void. The avenue of inquiry focused on the physics of hypervelocity collisions. Unlike asteroid impacts within our own system, where relative velocities can reach dozens of kilometers per second, interstellar collisions magnify the scale of violence. An object like 3I Atlas moves through the solar system at tremendous speeds, already tens of kilometers per second faster than most local debris. When struck by another body, even one comparatively small, the kinetic energy unleashed is extraordinary. Researchers began simulating the event on supercomputers, modeling the shockwaves that must have propagated through the interstellar traveler's structure. These simulations suggested that layers of frozen volatiles could have explosively decompressed, shattering crusts and exposing deeper cores. Such a sudden release would explain the anomalous pulses of light recorded after the impact, as gases vented into space and caught the glare of distant sunlight. Equally significant was the question of composition. Prior to the collision, astronomers had studied 3Y Atlas primarily through its reflected light. Such observations provided broad hints about its makeup, but little detail. The impact tore away the secrecy of its surface, throwing fragments and vapors into detectable plumes. The debris cloud became a treasure chest of information. Some particles reflected in ways suggesting crystalline structures unlike those found in most solar system comets. Others showed traces of metals alloyed in unusual ratios, pointing to conditions of formation different from anything in our local neighborhood. These clues hinted at alien geologies, at planetary building blocks shaped under alien suns. From here, the implications rippled outward. If 3I Atlas carried such exotic material, then the systems that birthed interstellar wanderers may have architectures very different from our own. Perhaps they contain planets forged under intense stellar winds, or disks enriched with heavy elements from nearby supernovae. The impact granted humanity a glimpse into those far-off nurseries of worlds. Every atom of debris now carried meaning, a fragment of a story written light years away, delivered by chance into our telescopes. At the same time, the event stirred unease about the mechanics of detection. For decades, astronomers had known that most small bodies in space remain invisible until they are close. Even large asteroids within our solar system often escape cataloging until they approach Earth's vicinity. Interstellar objects traveling faster and dimmer than most are even harder to spot. The body that struck 3I Atlas was itself unseen until the collision revealed its existence. That invisibility troubled experts in planetary defense. It underscored the fragility of Earth's shield, for if such a body had instead crossed paths with our planet, there would have been no forewarning. To grasp the scale of the danger, researchers turned to energy calculations. A body only 100 meters across, moving at the speeds common to interstellar trajectories, carries an energy release on impact comparable to many thousands of nuclear detonations. On Earth, such an event would erase cities, carve craters, and alter climates. Yet we had no prior record of its approach, no chance to prepare. The lesson was chilling. The universe contains bullets we cannot yet see. The collision with 3I Atlas did not merely expand knowledge, it illuminated ignorance, reminding us of the limits of surveillance in an uncaring cosmos. Philosophers and cultural thinkers quickly joined the discussion, reflecting on what the collision symbolized for humanity's place in the universe. For centuries, the night sky has been imagined as serene, its stars and planets fixed in predictable order. Events like this shattered that image. The heavens are not still, but turbulent, filled with unseen objects colliding, breaking apart, and reforming in endless cycles. Our solar system is not immune to these dramas. It is merely one stage among countless others. To recognize that chaos intrudes even into the paths of visitors from other stars forces a reevaluation of cosmic safety. Stability, it seems, is only an illusion. Another layer of inquiry arose from the altered trajectory of 3Y Atlas. The collision had imparted a measurable shift in its motion, redirecting it slightly from its predicted course. That deviation, though small, was enough to demonstrate how fragile the pathways of interstellar wanderers truly are. A single impact can redirect their fates entirely. For astronomers, this presented a puzzle. If interstellar bodies can be altered mid-flight by collisions, then their histories are more complex than imagined. Some may arrive here not by straight escape from their home systems, but by a series of deflections across light years. Each impact becomes a chapter in a long journey, making every interstellar visitor a product of countless random encounters. This raised an even deeper question. What if some of these bodies carry with them the scars of ancient collisions that once took place in other systems? Their surfaces, their trajectories, even their internal compositions may be living archives of interstellar turbulence. To study them is to glimpse not only other stars, but the collisions and accidents that shaped those stars' planetary systems. The strike on 3I Atlas revealed this principle in the most vivid way possible, showing that collisions are not rare exceptions but threads woven into the very fabric of cosmic migration. Excitement mounted when astronomers speculated about the chemistry of the exposed interior. Some observations hinted at unusual carbon compounds, long-chain molecules more elaborate than those commonly found in comets from our own system. While caution ruled out premature conclusions, the prospect of encountering prebiotic or proto-organic material from another star was intoxicating. Such molecules, born under alien suns drifting into our skies and then revealed by a sudden violent impact, spoke to the universality of chemistry. If these structures truly existed within 3I Atlas, it would mean the seeds of lifelike chemistry are scattered not just within the Milky Way, but across its drifting wanderers. Biologists and astrobiologists leaned into this possibility. They argued that if interstellar debris can transport complex molecules, then panspermia, the idea that life's ingredients travel between stars, may not be mere speculation. The collision, by breaking open 3I Atlas and allowing humanity to glimpse its internal chemistry, may have provided the first tangible hint that life's building blocks migrate across stellar boundaries. The terror of the impact merged with awe as the violence of space revealed a delicate thread linking systems, linking worlds, and possibly linking lives. But the terrifying aspect persisted. If complex molecules ride interstellar bodies, then so too might pathogens or alien biochemistries beyond comprehension. While most experts dismissed the notion of viable organisms surviving such journeys, the thought lingered. What if the fragments of 3I Atlas carried more than inert chemistry? What if someday a collision sprayed material across a planetary atmosphere? The event reminded us that cosmic exchange is not always benign. It can be both the bearer of creation and the herald of catastrophe. Beyond the laboratories and telescopes, public imagination surged. News of the collision spread rapidly, sparking fascination among the general population. Artists depicted the moment as a cosmic duel. Storytellers imagined hidden messages inside the shattered traveler, and filmmakers dreamed of future missions to chase the debris. For ordinary people, the impact was not just a scientific curiosity, but a narrative of wonder and dread, proof that the universe is both breathtakingly beautiful and unpredictably violent. Technological implications also began to unfold. Agencies tasked with planetary defense and space exploration revisited their priorities. The realization that unseen interstellar debris could strike without warning fueled urgency for better detection systems. Proposals emerged for deeper space telescopes, instruments that could scan the darkness far beyond Earth's orbit for dim, fast-moving bodies. Others suggested swarms of robotic scouts placed across the solar system, acting as sentinels against wandering hazards. The collision with 3I Atlas was thus reframed not only as an event of cosmic drama, but as a call to arms for planetary vigilance. Engineers and physicists also considered what such an impact could teach us about shielding spacecraft. As humanity dreams of missions to Mars, to the outer planets, and eventually to interstellar space itself, the hazard of high-speed debris looms large. A fragment of the size that struck 3I Atlas could obliterate any spacecraft we currently design. Understanding the physics of that impact offered clues about what materials or structures might resist such forces. In this way, terror became a teacher, guiding innovation through its demonstration of vulnerability. As more data poured in, new mysteries surfaced. The debris cloud from the impact began to disperse, but its behavior was not entirely as predicted. Certain fragments glowed faintly in wavelengths that hinted at ongoing chemical reactions, as though 3I Atlas had been holding volatile compounds under pressure for eons, only for them to ignite once freed. These anomalies sparked speculation about exotic ices, materials stable only in the deep cold of interstellar space, now breaking down under the warmer influence of the solar system. To witness such chemistry was akin to watching an experiment billions of years in the making, triggered in an instant by an unforeseen strike. This revelation deepened humanity's understanding of interstellar survival. For an object to travel light years, it must endure radiation, collisions with dust, and the emptiness of space without disintegrating. The fact that 3I Atlas harbored intact volatile compounds suggested resilience beyond expectation. Perhaps interstellar bodies are tougher than we think, capable of protecting their interiors for millions of years. That resilience had profound implications. If such travelers can preserve delicate materials for vast stretches of time, then the likelihood of them transporting meaningful chemistry across galaxies increases dramatically. Meanwhile, the human psyche wrestled with the symbolism of the event. For millennia, cultures have seen comets and unusual celestial phenomena as omens. Though modern science dismisses superstition, the instinctive awe persists. The idea that an object from another star could be struck so violently in our neighborhood seemed laden with meaning. Was it a reminder of our fragility, a warning of unseen dangers, or simply another reminder that the cosmos is indifferent, assigning significance only because we choose to perceive it? These reflections added a layer of existential weight to the scientific discussions, binding humanity's emotional response to its intellectual pursuit. The sheer improbability of the collision continued to dominate conversations. Statisticians struggled to calculate the odds of such an event occurring within human observation time. Some propose that interstellar space may be denser with unseen debris than models suggest. Perhaps the galaxy is far more crowded, with countless bodies crossing paths silently and unseen. If true, this would redefine not only risk, but also the nature of galactic evolution. Each collision becomes a sculptor of orbits, a driver of planetary ejections, a hidden hand in the architecture of systems. Other thinkers considered whether this event hinted at still stranger truths. Could there be mechanisms guiding such collisions, gravitational focusing, unseen streams of debris shepherded by galactic tides? If so, then 3I Atlas's fate was not mere chance, but the product of subtle, invisible structures spanning light years. To imagine such hidden currents of cosmic matter is to reimagine the galaxy not as empty, but as alive with invisible rivers and crossroads where wanderers collide. As days passed, more refined observations revealed yet another surprise. The rotation of 3I Atlas had changed. The impact had not only altered its path, but also imparted spin. This rotation provided fresh data about its density and internal structure. By measuring how quickly it turned, astronomers could infer whether it was a solid monolith or a loose rubble pile bound by gravity. Early data suggested a surprising cohesion, more solid than expected. This contradicted assumptions that interstellar objects would mostly resemble loosely bound comets. Instead, 3I Atlas appeared sturdier, hinting at violent origins where only the toughest fragments survived ejection from their home systems. This sturdiness carried sobering implications for planetary defense. A dense, solid interstellar body striking Earth would cause far more devastation than a fragile comet of the same size. Our strategies, often designed with fragile asteroids in mind, might prove inadequate against such visitors. The event thus became a training ground not just for science but for survival, reminding us that the unknown is not only fascinating but dangerous. In a broader sense, the collision forced humanity to confront its cosmic vulnerability. Earth orbits serenely around its star, life thriving under a thin veil of atmosphere. Yet beyond that veil, the universe is anything but serene. High-speed wanderers roam freely, and collisions reshape destinies without warning. The event with 3I Atlas underscored that we live not in a fortress, but in an open field under a storm of unseen arrows. This recognition is terrifying, but it also galvanizes resolve to understand, to prepare, to adapt. The story of 3I Atlas became a mirror, reflecting both our limitations and our potential. It reminded us that while the universe can deliver fear in an instant, it can also deliver opportunity. Through its violent encounter, the interstellar traveler offered a window into chemistry, physics, and cosmic history we could never otherwise access. It showed that terror and knowledge are intertwined, that sometimes the most frightening events are also the most enlightening. As telescopes continued to track its altered path, 3I Atlas slowly faded into the background of stars. Yet the memory of its collision lingered, etched into scientific papers, into public imagination, and into humanity's evolving awareness of its place in the cosmos. What hit 3I Atlas was terrifying not because it destroyed a traveler, but because it revealed truths we had long ignored, that the galaxy is alive with collisions, that we are never as safe as we believe, and that knowledge often comes hand in hand with fear. Even now, the echoes of that strike ripple outward. Every time astronomers point their instruments at another faint, fast-moving speck, they will remember the night when something unimaginable struck an interstellar visitor. They will remember the terror, the awe, and the flood of questions that followed, and they will know that beyond every flicker of light lies the possibility of another revelation, waiting to shake us from complacency, waiting to remind us of the vast and unpredictable theater in which we drift. The violent strike on 3I Atlas had not only unsettled astronomers, but also ignited new branches of exploration across disciplines that might not ordinarily intersect with astronomy. The event became a crucible where physics, chemistry, philosophy, engineering, and even art collided in parallel, mirroring the cosmic impact itself. Each angle revealed new implications that stretched far beyond the immediate spectacle of one interstellar traveler being struck by an unseen body. One of the most fascinating avenues was the study of the shock mechanics involved. Hypervelocity impacts are unlike anything we can reproduce fully on Earth. In laboratories, researchers can accelerate projectiles to several kilometers per second, but the speeds involved in interstellar collisions are an order of magnitude greater. The energy released when the unidentified body struck 3I Atlas exceeded what could be tested in any chamber. Scientists began using advanced particle accelerators and plasma facilities to simulate fragments of the collision at smaller scales. By examining how crystalline structures fracture under extreme conditions, they tried to reverse engineer the processes that ripped 3I Atlas apart. In doing so, unexpected insights began to emerge about the physics of stress distribution in bodies that have traveled between stars. The collision showed that 3Y Atlas had likely developed microfractures during its journey, caused by constant bombardment with cosmic rays and interstellar dust. These weaknesses became pathways for the energy of the impact, causing its body to fracture in asymmetrical patterns. Understanding these stress networks offered astronomers a new method of estimating how long an interstellar traveler had been adrift. In essence, the violence became a clock, its fractures a timeline of endurance in the interstellar void. Meanwhile, chemists turned their attention to the debris cloud. Some of the ejected material, while faint and distant, revealed spectral signatures suggesting the presence of exotic ices, molecules that cannot survive long in the warmth of the solar system but can remain stable in deep interstellar cold. These included compounds of nitrogen, oxygen, and carbon in unusual configurations, hinting at conditions of formation that diverged sharply from those of the primordial solar nebula. The discovery pointed to the possibility that other systems might produce reservoirs of substances we rarely encounter at home, shaping alien comets, planets, and atmospheres in ways we had never before considered. Astrobiologists were quick to recognize the significance. If exotic ices can survive the voyage across interstellar space, then so too can more delicate compounds. That realization raised the possibility of chemical continuity across the galaxy. The chemistry that seeded life on Earth may not be isolated. It may be part of a vast galactic circulation of molecules, exchanged through impacts, ejections, and collisions like the one witnessed with 3I Atlas. In that sense, the terrifying impact became a reminder that even destruction can be a vehicle for creation, dispersing materials across the cosmos that might one day serve as the foundation for biology elsewhere. The philosophical weight of that possibility was immense. Humanity has often wrestled with the question of uniqueness, whether we are singular in the universe or merely one expression of a broader tendency toward life. The strike on 3I Atlas subtly shifted that conversation. It was not simply about whether life exists elsewhere, but whether the raw ingredients of life are perpetually exchanged, like seeds carried on galactic winds. If so, then the galaxy is less a cold void and more a living ecosystem, its members connected by the circulation of matter across incomprehensible distances. Parallel to these reflections, engineers and mission planners considered practical implications. What if humanity could someday capture fragments of such interstellar objects? Missions to comets within our own system had already been accomplished. Rosetta had landed on 67 P/Churyumov-Gerasimenko. Stardust had returned dust samples, and others were planned for the decades ahead. But an interstellar fragment offered something far more valuable: a direct sample from another star system. The collision had inadvertently scattered such material, though at distances and velocities that made recovery impossible with current technology. Nevertheless, the concept inspired discussion of missions designed to intercept future interstellar bodies to collect debris in situ before it vanished back into the abyss. These concepts quickly grew bold. Ideas emerged for solar sail spacecraft that could accelerate rapidly to intercept visitors. Others suggested positioning long-lived probes at the edges of the solar system, waiting for interstellar travelers to pass within reach. What once seemed a distant dream became a pressing necessity, because the strike on 3Y Atlas showed that such visitors are not only real, but can change dramatically in moments, offering fleeting opportunities to learn about the wider galaxy. The cultural impact of the collision was also profound. Beyond scientific circles, the story captured imaginations. Writers described the event as a cosmic drama, likening 3I Atlas to a messenger from the stars ambushed before it could complete its silent journey. The symbolism resonated with ancient human stories of travelers, pilgrims, and emissaries cut down before they reached their destinations. It reminded people that the universe itself can mirror the archetypes of myth, telling stories through matter and motion that feel deeply familiar. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on 3I Atlas being suddenly hit unexpectedly? We want to hear from you. Thank you for watching, and see you next time.